Okay, so we've gone through the basics of solving quadratics using square roots when they're of the form ax squared plus c. That was our original question. We've also already taken a look at how many solutions we have. In that last example we did, we ended up with a conventional case of 2 solutions. But now we're going to get into some additional examples. Some of them should be pretty familiar. Some of them introduce a few new wrinkles. And we'll also take a look at an instance where we have a problem that only has one solution, and yet also does not have that solution be x equals 0. So for number 11, the wrinkle that we're seeing this time is last time we saw 4 sitting on the outside and we needed to divide by it first. This time we have 2x plus 1 on the inside of our parentheses. And what's pretty nice about this is that I would say it's actually probably easier than what we did on number 10 because we don't even have to do any setup before we take our square root. We just immediately begin by taking the square root of both sides. The square root of 2x plus 1 squared is just 2x plus 1. And the square root of 36 is going to be plus or minus 6 because 6 times 6 is 36. But we also we're also living in a world where potentially we could have a negative 6 make up that 36. So what do we do from here? Well, we subtract 1 from both sides, and we end up with 2x is equal to negative 1 plus or minus 6. Now, at this point, I'm actually going to go ahead and choose to split this into 2 separate problems. So the first problem is going to be 2x equals negative 1 plus 6, and then we have 2x equals negative 1 minus 6. Now, negative 1 plus 6 gives us a positive 5. So we have 2x equals 5. We divide by 2 in order to get x alone, and we end up with x is equal to 5 divided by 2, or 2.5. Likewise, 2x equals negative 1 minus 6. Well, that equals negative 7. We divide by 2. We get x is equal to negative 7 divided by 2, or negative 3.5. Once again, we have 2 solutions. And again, not a whole lot of exciting stuff happened here. I mean, we did have to do multiple steps after we took the square root, in contrast to the last problem where we only had to do the 1 step, not counting splitting it into 2 problems, but we only had to do the 1 step. Well, also not counting all this foolishness with taking the square root of a fraction. But ultimately, there wasn't much to do after we took that square root. But in this one, we ended up actually having 2 rather distinctly different problems where we had to divide by the 2 after we separated the 2 equations, which isn't really anything too onerous, but it is just one extra wrinkle you can potentially see when you're solving for these. But ultimately, it doesn't make it significantly more difficult. Now, at this point, we've seen most of the possible wrinkles we can see, and we're going to take a look at 2 pretty conventional examples here. So in number 12, we see we have 12x squared plus 1. And this one conveniently doesn't have any junk with the x inside the parentheses. So we're actually just able to directly solve this one pretty fast by subtracting 1 from both sides. So we have 12x is equal to 12. We divide both sides by 12, leaving us with x squared is equal to 1, because 12 divided by 12 is, of course, 1. We take the square root of both sides, giving us x equals plus or minus 1, because 1 is the square root of 1. It's the only number you can multiply. 1 is the only whole number you can multiply in order to make 1. And if you think about plugging this back in, well, 1 squared makes 1. Negative 1 squared also makes 1. So 12 times 1 is 12. Plus 1 gives us the 13 we need. On example 13, if you can believe it, is functionally the same as example 12, because instead of subtracting 1, we now subtract 7 this time. So we have 6x squared is equal to, what is that, 348. And then we need to divide by 6, just like we divided by 12 before. And I'm going to be completely honest. Offhand, I have no idea what 346 divided by 6 is. So I'm going to go ahead and use the calculator. And the calculator tells me that 348 divided by 6 is 58. So we have x squared equals 58. And I'm actually going to double check that just because I already anticipate this is not going to come out looking very nice. So yes, 348 divided by 6 is indeed 58. And just like we did in the previous problem, we need to take the square root of both sides. That gives us x equals plus or minus the square root of 58. Now, we need to check to see if 58 can have anything factored out of it. So I'm going to do that over here. We have the square root of 58. What are numbers which multiply to make 58? Well, one of them I know is 2. And I'm not 100%. The only reason I know 2 is one of those numbers is because 58 divided by 2 is, well, 58 is an even number. So 2 has to go in it. But I don't know what times 2 makes 58. Well, I checked on my calculator off screen, and that is a 29. 29 is unfortunately a prime number. So 58 cannot be simplified at all. So our solution is simply x is equal to plus or minus the square root of 58. All right. Well, number 13, despite having some scarier numbers and needing to appeal to the calculator, was actually as easy as number 12 was, which was pretty cool. But now what we need to do is we need to take a look at a couple of unusual examples here with 14 and 15. And these are the ones I was promising earlier, where we would have something with a single solution. Both of these had 2 solutions, in case it wasn't obvious, by the way. -1 and +1, and negative square root of 58 and positive square root of 58. This one will only have one solution. So as you can see, it begins with x minus 2 quantity squared is equal to 0. So we begin by taking the square root of both sides. That gives us x minus 2 on this side equals the square root of 0. Well, the number that you multiply to make 0 is 0. Plus or minus 0. Wait a minute. We talked about this earlier. There's no such thing as plus or minus 0. There's only 0. Then we need to solve for x by adding 2 to both sides. And we get x equals 2. Not plus or minus 2. Just x equals 2. Because if you look at the original equation, if you plug in 2, 4, x, 2 minus 2 equals 0. 0 squared equals 0. If you put in -2, for example, -2 minus 2 is -4. And -4 squared gives you a +16. So this one has one solution. And as you can see here, it ends up starting with equals 0. So essentially, if at any point you need to take the square root of 0 when you're doing one of these problems, you're going to end up with one solution. That was what ended up happening on that example way back in the second video. We took the square root of 0 here. It just so happened that there was nothing inside the parentheses around x underneath the square root, or underneath the square, excuse me, that would cause us to get a solution other than 0. Example 15 is going to end up working the same way, although we're going to go through a little bit more of a song and dance to get there. Because just like example 10, we need to get rid of that 3 that's sitting out in front of our parentheses. So we're going to start by dividing by 3. That gives us 3x minus 5 squared equals 0. Then we take the square root of both sides. That gives us 3x minus 5 on the left side, but the square root of 0 is just 0. So this one is also going to only have one solution. So we need to do our opposite operation to get our x term alone by adding 5. That gives us 3x equals 5. Then divide by 3. And we get x equals 5/3. One solution. And I'm not going to bother to put this in decimal form because the decimal is non-terminating. So that should give you a pretty good idea of chapter 9.3, solving using square roots. And I hope that this will be something that after doing it, you'll be like, thank goodness, I no longer have to factor these problems, because factoring these problems is no fun at all. Because it's a lot of work just so you can arrive at the conclusions we've been seeing here, which we were able to do in just a handful of steps. Well, except for that part when we had to simplify the square root of a fraction. That was a little bit more of a challenge, but we got there eventually. This is definitely the easiest option we have available to us. So once you're done watching this video, you should be well equipped to begin on the Big Ideas assignment for section 9.3.